Tom Jones, we hear that this trip is environmental in purpose, and I gather the six of you are working 24 hours around the clock. Is that right?
That's right, Charlie. We've been busy since Friday. We got right to work after lunch. We have two teams of astronauts, 3 people on each team. I'm on the blue shift. We've been working the night shift, essentially, for folks back home. And we've been studying the world's changing environment around the globe.
Well, it's the night shift for the folks back home, but it's the night shift, day shift, then night shift, then day shift, I know, for all of you. As I talk to you, where are you right this moment?
Charlie, we're coming up on Western Australia right now, and we'll be passing up through the Pacific Ocean along towards North America in about 30 minutes.
Now, Tom, this space radar laboratory that you have in the payload bay there, it is designed to do what?
Space Radar Laboratory, Charlie, is an example of a set of instruments, state-of-the-art instruments that are designed to monitor the Earth from space. And we hope that this test bed out in Endeavour's cargo bay will prove the technique of remote sensing of the Earth on a permanent basis. So the flight last April of Space Radar Lab 1 and the second flight that we're conducting right now are designed to prove the technique of space radar and an infrared pollution sensor to monitor the Earth's atmosphere and surface on a day-to-day, week-to-week, even a year-to-year basis. So we can really keep tabs on both natural and man-made changes around the planet.
Well, I gather that you're able to compare the pictures that were taken from the space flight in the spring and the pictures that you're getting now. But tell me specifically what kinds of things you're looking for with this sophisticated radar system.
Well, the beauty of the radar system is that we can tune it to look at just the phenomenon on the surface that we're interested in. So for the United States' central region, for instance, we can look at agriculture and soil moisture. And so we're examining the differences in the moisture content of the breadbasket of the U.S. and the Great Plains from last April to the present. We're looking in the tropics and in the far northern hemisphere for changes in the forests around the world to see the progress that's been made in clear-cutting or destruction of the forest, to see whether the forest is regenerating itself in other areas. So those are ecological changes that we're looking at. More dramatically, we can also look at geological changes on the surface by tuning the radar to look for volcanic activity. And we saw a very dramatic example of that up in Kamchatka on Friday and Saturday. In fact, we're examining about 15 volcanoes around the world that are hazards to very populated areas and parts of the globe.
Yes, I guess it was a real stroke of luck that you had the explosion of the Russian volcano just hours after you took off. And I gather the first thing you did was go to the window with a regular handheld video camera and take some pictures of it, which we're going to be showing. But then also you've had the radar imaging of that volcano as well.
That's right, and the way we use the radar in looking at volcanoes is to look at their past by looking at the lava flows and ash deposits on their flanks. That tells us a lot about the way the volcano has behaved in the past, and that will tell us about the future potential for hazard to people who live around there. For example, Mount Rainier up in the northwest U.S. is a recently active volcano, yet we have hundreds of thousands of people living within range of the destructive path of a future eruption. So by looking at the layers of lava flow and ash deposits, we can sort of predict the kinds of activity we have to watch out for in the future. And it just so happened we were lucky enough to catch a vivid example of that up in Kamchatka. That just helps us learn more about volcanoes all over the globe, like Vesuvius near Naples, Rainier is another example, and some of the volcanoes down in Central and South America.
Now, as we look at the radar pictures that you also took of this Kamchatka volcano, the colors, I guess, are different than what we'd normally see, but what actually shows where the lava flow is?
In the images that we've had uplinked here, and I think the ones that have been released to you, there are new lava flows that are visible as red paths going down the volcano, and some of the more recent ash deposits show up as greenish or gray areas that are sloping down the sides. And so we can use the different radar frequencies as sort of a way to make a color photograph of the ground, even though that's not the way it appears to the naked eye. And so these colors represent different kinds of rocks or ash deposits, different lava types, if you will, on the ground. And that's the way we unravel the past history of a mountain like Kluchevskoy.
Tom, is it necessary to have astronauts up with this kind of radar, or will eventually we permanently orbit this sophisticated new radar for, in effect, permanent mapping or imaging of the Earth?
Well, fortunately for us on board, it is necessary for the crew to be here to prove that this test bed system works out in the cargo bay. We're here to make sure that all the data gets back to the ground. We're here to make sure that where we don't have scientific teams around the world, the crew can take photographs to document the radar's data and prove that it's correct when we get back to the Earth. And we're also doing a lot of pointing of the shuttle to make sure the radar gets right on target. Now, all of those techniques can be automated later on, and we hope that the success with Space Radar Lab 2 and 1 will show that this is a good technique for a permanent installation. So perhaps as part of the Earth observing system around the turn of the century, we'll be able to have a permanent radar platform that can watch the Earth 24 hours a day through darkness and clouds, just like we've been doing this week.
Tom, we've lost picture, I think, for a minute. We've lost picture for a minute, and I'm told it's going to be back just momentarily. So I'll actually go back and ask you to do the last part of that answer again, and then we'll pick up as soon as we've reestablished picture contact.
Okay, that'll be fine.
Good. Tom, just one other thing. As soon as we finish, and I've got just a couple of more questions, I'm going to ask you to do what we call a face, which is that we use at the beginning of the half hour. I'll just ask you to say, "I'm Tom Jones, coming to you from 125 miles over the Earth from the Space Shuttle Endeavour, and Good Morning America." If you do that when we finish before we sign off. That allows us to say
Surely.
yes. If he's heading, no, he wouldn't be. If he's off Western Australia heading over the Pacific Ocean, he wouldn't be in a sunrise yet. Okay.
Charlie, it's more like a sunset. We had that about 5 minutes ago.
Had a sunset about 5 minutes ago?
That's right. Every 45 minutes we get one or the other.
I don't know how you don't. Joan London and I talk about this job, Tom, as having permanent jet lag. I don't know. I don't know how you wouldn't have permanent jet lag in a situation like that.
Fortunately, we get our clock shifted before we launch, and so once we get up here, we're on internal body clock, and we don't have to worry too much about the confusing cues outside.
All right, let me. We've now got reestablished picture, Tom, and let me simply finish up on that question about: is it possible that eventually we would permanently have this kind of radar in space rather than just an occasional trip on the shuttle?
Well, we certainly hope that the success of Space Radar Lab 1 and 2 will show that this is a very useful method for permanent monitoring of the Earth. It's a very versatile technique that can look at almost all aspects of the Earth's surface, and the map sensor on board helps us looking at pollution in the atmosphere as well. So a suite of these kinds of sensors would certainly be appropriate, we hope, as part of the future mission to planet Earth around the turn of the century. Fortunately for us, on board the crew of Endeavour, we had the chance to accompany this testbed radar on the second of its flights, and we're here to bring all the data back. We have a lot more than we can send down to the ground by radio, and we have a lot of information in addition to the radar data that we can bring back from photography. So we're helping prove that this testbed instrument works, and we'll be happy to see it in a permanent orbit someday in the near future.
Tom, to try to put this into perspective for me, the layman, I get the idea that this radar is kind of like an even more sophisticated AWACS planes, those planes that fly around and we told have such incredible radar. I'm wondering just, first of all, is that analogy right? And second of all, just how minute an object on Earth can you see from so high?
I think that's a good way of looking at it. This might be an environmental AWACS, if you will, and it would be able to keep tabs on rapidly changing developments like forest fires, floods, volcanic eruptions, as well as track the more slow but just as important changes like forest clearing and agricultural and snowfall and ice pack changes around the world. So it is a good analogy. With this kind of a system, we can see down to objects as small as about 20 meters, about 65 feet across, and that's just about the resolution we need to look at these broad-scale phenomenon. We don't have to use the same technology that reconnaissance platforms might have to use.
Well, if you could see something 20 yards long, then you could pick out Three Rivers Stadium last night in Pittsburgh where Houston got beat?
That's certainly true. We'd be able to pick out features like that. I'm glad we weren't able to see that particular game.
Tell me, did you still have that mosquito on board? I understand when you launched there was a mosquito flying around.
Well, we have what's left of the mosquito on board. He must have sneaked on board when we had the hatch open prior to liftoff. But we still have 6 happy campers up here.
With no mosquito bites. Tom, thank you very much. Good to talk to you.
It's good to be with you, Charlie. Thanks for talking with us.
By the way, in the few moments that we have been speaking, you said you started out in Western Australia. How far have you gone?
We've been traveling about 5 miles a second, so we're well east of New Zealand now and starting our upward swing across the Central Pacific.
Tom Jones, good to talk to you. Happy landings.
Thank you.
Now, Tom, before we sign off with Houston, if you could do that, what we call the face. If you could, Tom Jones, and I'm 120 miles up, Station Endeavor. Good morning, America. Thanks. When you're ready.
Hi, I'm Tom Jones aboard the Space Shuttle Endeavor. We're 134 miles above the Earth this morning. Good morning, America.
Terrific, Tom. All the best to you. Thank you very much. God bless.
Thank you.
In just a little more than an hour from now, the red team will begin a handover and relieve their blue team counterparts. The red team's been awake for about a little more than an hour on board.
And Dan, I see you looking at the 2 messages there. What we've done is steps 1 and 2 have taken the applicable things out of the orbit ops checklist and just put them on the message for you. Steps 3A, 3 Bravo, 3 Charlie, and 3 Delta are essentially the same. And for your upcoming burn, we'll have you do steps 1, 2, 3 Alpha, and then 3 Delta.
Roger that. So we'll just do steps 1, 2, 3 Alpha, and 3 Delta.
That's correct, Dan. We just wanted to include all the checks for the RJDs, the DDUs, the pressure checks and all that on the message for you so you didn't have to be jumping back and forth.
Roger that.
Endeavor is directly above Florida at present on a course that will take it to right up the east coast of the United States. Observations with the Space Radar Lab ongoing as Endeavor continues up the east coast include observations in Pennsylvania, at Howland, Maine, and also the Gulf of St. Lawrence. Endeavor's just completed an observation above the Gulf of Mexico and above southern Mexico.
Okay, Dave, go ahead.
Okay, Bakes, what we've done is the POC has taken data from your prior passes and interfered it against 59 data, and it's come out so good that this has become an important priority. And we are switching to the trajectory to match STS-69. We will still get most of the same data from STS-68 originally planned passes, but there will be modifications to the data takes and ADLs, and we'll be getting those to you. Again, we're switching to the STS-69 reference trajectory due to the excellent data obtained by interfering 68 data with 59 data.
Okay, great. Sounds good. That's really good news about the interferometry. It's a pretty good tribute to the orbiter and the people who designed it and operate it to be able to repeat their orbits from flight to flight like that.
Bakes, understand, it is just incredible data that we're getting to interfere against STS-59. We're extremely close to the orbit of STS-59 over the Earth. It's just an incredible vehicle that can accomplish this. Endeavour will actually be within roughly 30 feet of the point in space above the Earth of the STS-59 orbit.
Unbelievable.
And Endeavour is now moving across the northwestern portions of Africa. Again, using the synthetic aperture radar, it's very evident that the orbiter is now crossing over land. This is a geological site, a super site again, over the Sahara Desert area. The Sahara is an area which is about the size of the United States. Prior to its becoming a desert area, it had been apparently well laden with fairly major drainage networks. With increasing dominance of the wind and the sands in the channels and the various floodplains of the rivers began to be reworked into thin sheets and eventual scattered dunes. These widespread deposits eventually masked the tertiary areas of the region and began to hide many of the river systems from view. And that was prior to the advent of the first flight of a spaceborne imaging radar system.
I have one item of fairly large earth-shaking news. Earlier today at approximate MET time of 2 hours and 7 minutes, there was a 8.2 earthquake about 125 miles east of Japan with the following coordinates: 44 degrees north, 147.4 degrees east. The first landfall came a few minutes later. It's estimated we don't have reports of damage from the tsunami yet, but over time our planners right now are attempting to redirect some upcoming data takes to image key spots where the tsunami may have hit the islands of Hokkaido and further south. You'll be flying over there in the darkness until later on in the mission at orbit 76, but you can expect some changes to the IST probably on the next Q card. And that's all I have. Any questions?
No, we copy all that. We'll try to give you our observations, and while that's terrible news for Japan, it's an opportunity for the radar.
That's correct. Okay, we'll talk to you later.
As Endeavour moves out over the Gulf of Mexico, the Space Radar Laboratory instruments are taking data for oceanographic studies. This is Mission Control Houston. We're now receiving some additional real-time downlink from the synthetic aperture radar instrument in Endeavour's payload bay as it flies 118 nautical miles over the coast of Japan. With us again is Dr. Jeffrey Plout, the geology representative for Circe XR. Dr. Plout, what are we looking for in these XR images?
Well, at this point, we're traveling over the Sea of Japan, and this is an inland body, not an inland body. This is the strait between the main continent of Asia and Japan, and we will be coming up shortly on the Sarobetsu test site, which is the northern tip of the island of Hokkaido, which was the vicinity of the offshore earthquake earlier today.
Dr. Platt, is there any possibility we'll see any change in the shoreline because of the waves that have been in the area?
That is the type of observation that we would be interested in making, and in this case, perhaps looking for ponded water or any bright radar returns from the nearshore area. Here we're coming over the southwest corner, and then beyond, in the top of the screen there, is the northeast section of the island, and there's no obvious evidence of damage, but this is going by rather fast, and we'd certainly need more time to sit down and do a detailed processing and analysis of the image. Going by there is a small island peninsula off of Sakhalin Island, which is north of Hokkaido.
Once again, we're receiving live downlink television pictures, these coming from the payload bay of the shuttle Endeavour as it passes over the area of Sonora, Mexico.
Jeff, this is Ed Hughes at WTKR in Norfolk. Can you hear me?
I can hear you. How do you read me?
Okay, I got you. We got a little bit of a delay, and we've lost some time. But let me ask you, you've got to be thrilled about this mission. Radar works well in space when it's checking what's happening with global warming and our environment. You've got to be thrilled about that.
This is a really super mission. It's one of the really important things that we can do in space is to study the changes going on the Earth. both natural and man-made, and this is a fantastic instrument. It includes 3-frequency radar. It's a multi-country effort, and it also has an instrument for measuring the carbon monoxide in the atmosphere, which plays an important role in perhaps the cycle of ozone in the atmosphere. So this is an amazing instrument, and it's really proved itself over a mission a couple months ago, and so far our mission has been working superbly.
A little bit earlier this afternoon, you passed over Japan. We mentioned that earthquake. We got to see, of course, the ground pictures. What were you able to observe from the shuttle Endeavour as far as that earthquake was concerned?
Our passes over Japan on our shift, actually Japan is in very low light. The sun is just rising. So from our point of view on the red shift, which is made up of myself and the commander and pilot, we can't see anything visually. You'll have to ask the blue shift, which is just waking up now and coming on to shift. They'll be observing over the next day, and hopefully we'll have some visual observations of any changes they could see.
You're able to do this in all kinds of weather. You're able to do it night and day, as you just said. But what about the rain? Did you do some kind of an experiment to see how the radar would work over the rainy spots?
Yeah, one of the important things that we can do as observers on board is to tell the folks on the ground when we're passing over thunderstorms that may be included where the radar is looking. Since the radar has 3 different frequencies that it operates at, it has the capability of penetrating weather, but to a different degree on each frequency, and that's part of the important aspects of this instrument. It allows them to measure soil moisture at different depths and measure the quality of wetlands around the world and how they're changing. But they are affected by very heavy thunderstorms, and they can image those. And one of the first things they did, which was very novel on the last mission with this radar, was they actually imaged rainfall for the first time from very heavy storms in the Pacific.
All right, Jeff, we're out of time. I'm sorry we lost you earlier, but your mom and dad are watching. I'm sure everybody at Norfolk Academy is watching, and our good friends over at NASA Langley. Thank you, and have a good mission.